And welcome everybody to the Daily Space Weather. Right now we're looking at the Sun, the northwesterly quadrant. In 131 angstroms, one of the ionized emission spectral states of iron. And this active region over here actually is a sunspot, which has gained in complexity a little bit. Over the past 24 hours, it's gained some trailing South Pole umbra, which means it's now a beta-class sunspot. More about that in a moment. We'll also be doing a snow update, talking about the 1582 solar storm, and about the fact that cosmology equals heliophysics. And now we're just looking at the solar intensity gram, and you can see this additional umbra form here, right there. That umbra comes into view, and that is opposite polarity. That is South Pole oriented, which increases the likelihood of solar flares a little bit, folks. There is also a coronal mass ejection watch in effect, and if you were a patron, thanks to our Patreons, you would already know that. By the way, the URL is patreon.com/smAsho. So here's a close-up magnetogram, and we're mainly focusing our attention on this area here, sunspot 2812, and you'll see the formation of that South Pole umbra in the magnetogram. And continuing on, here is a colorized magnetogram. And you can see this trailing umbra is indeed red, an indication that it is South Pole oriented. Here's some more close-ups. Here's 193 angstroms. Some major filaments off there to the right of the picture, near the Earth scale there. And they show up even more intensely in 304 angstroms, ionized helium. And here's that. And those filaments many diameters, the Earth. And again, there is possibility of coronal mass ejections. The likelihood goes up a little bit with the beta classification of that sunspot, as the likelihood of solar flares goes up with a beta class sunspot as well. Here's a diagram of the solar system. There's where things will be in a week. And if you look at Stereo A's imagery, it's now showing Mercury. We won't show it today. Here's a star chart. If you're up before dawn, you may see Saturn if you've got a clear view of the ecliptic and the southeastern horizon if you're in the northern hemisphere. The radio flux of the 10.7 centimeter variety is at 74. And for you new viewers, thanks for tuning in. The 10.7 centimeter radio flux is the most proportional data set we have to sunspot number in terms of solar sunspot cycles and solar polar field reversal cycles. Here is the one-year chart of that from solon.info. The black line here is the 10.7 centimeter or 2800 megahertz radio flux. 2800 megahertz is 10.7 centimeters. And here is the sunspot number chart as well. This red line on the bottom, that is sunspot number, again at 74. And here's a view of Venus on the LASCO C3. This is located at Lagrangian point 1. And let's take a look at some volcanoes, such as this one. A live feed of Fagradalsfjall. Yes, Fagradalsfjall, folks, as it turns into a shield volcano. We've seen part of the cinder cone collapse here. It's got two calderas really at the moment. and it's slowly filling the crater valley with lava. And let's see what else is erupting. Suwanosejima, it's producing a 7,000-foot ash plume. Sinabung, 11,000-foot ash plume over the world's deadliest volcano over the past few years. Pacaya in Guatemala, 11,000-foot ash plume there as it explodes. Fuego, also in Guatemala, exploding, 15,000-foot ash plume there. Revenador exploding. Flight level 140, it's a 14,000-foot ash plume as Revenador explodes. And we're unable to detect whether or not Sabancaya, the Peruvian volcano, is erupting. Consumer tip, please do not pole vault the caldera. And for that, we thank you. Next, we'll check seismicity. And we saw some quakes in odd places going on. Let's go up the list. First of all, a very shallow quake at Hawaii. I'll bet it's under Mauna Loa. Let's check, as the depth is 1.7 kilometers above sea level. And indeed it is underneath the western slopes of Mauna Loa, the world's largest volcano. At 1,700 meters above sea level is the depth, negative 1.7 kilometers. Guatemala saw a deep quake in the 4.4 magnitude range, and we see a Chinese quake at 5.6 magnitude over the past 24 hours. Timor-Leste saw a deep quake at 4.5 magnitude and 135 kilometers. I would note this 5.1 in the Beaufort Sea. Kind of an odd spot for an earthquake there. And that brings me to an important point. We've noticed a lot of fresh water in this area, which seems to be filtering out through this archipelago, as opposed to filtering out into the Gulf Stream, folks. Yes, it's true. And so perhaps all the fear-mongering about a year without a summer. Have we heard fear-mongering about a year without a summer? Anyway, we're not getting all that much fresh water over here. We're getting the fresh water in the Beaufort Sea. A good sign, as it doesn't necessarily correlate with a year without a summer. And continuing on to go back to some space data. According to the GOES-16, no solar flares over the past 3 days. Nothing even in a B-class range. Likelihood of solar flares now up a little bit with Sunspot 2812. Proton flux, no strikes in the proton flux, and no surprises to our viewers there, as we would have let you know. The GOES magnetometer over the past 3 days, pretty smooth here. And if you're new to the channel, the N's and M's stand for noon and midnight local time for the GOES-16 geosynchronous satellite. And let's take a look at magnetism here. Of the heliospheric current sheet, we're looking at the Earth in a North Pole-oriented current sheet now here shown in green. Keep in mind the data is 1 hour and 21 minutes old and can change with basically no warning at all. And here's a line of sight coronal hole plot. There is a North Pole-oriented coronal hole rotating into the Earth-facing zone. It was transequatorial, and now it has receded a little bit. And we'll look at the filaments and the detected groups next. And you can see the Sunspot 2812 here being listed as a beta-class sunspot. There are some filaments that are not showing up here on the detected filaments, and they're really in this region, sort of just south of the solar equator, folks. And the possibility of coronal mass ejections remains. KP index is at 1, And again, if you're a new viewer, that's a measurement of global geomagnetism. Speaking of which, here's a visualization of it. Actually, we'll show that after the real-time solar wind. Here's the real-time solar wind. And we just saw an uptick here over the past couple of hours. Now, just under 6 protons per cubic centimeter is the solar wind density. Solar wind speed still quite low at 334 kilometers per second. Other data points not particularly noteworthy on the real-time solar wind data. And here's a visualization, 4 hours of data of geospace. We'll let that play through as it's refreshed. And it's refreshing to see the most current data of the dynamic environment known as our solar system. So again, this is 4 hours of data. We may see the pressure come up here a little bit right at the end of the movie, as we saw that small uptick in the solar wind density, not really showing up there as pressure. Here are ground magnetic perturbations. We show it daily because we're living through a geomagnetic excursion. We've got 2 north poles, were you aware? There's one over Siberia and one over Canada. And the South Pole has left the Antarctic continent entirely, thousands of miles from the geographic South Pole, and is someplace south of Australia. We'll let this play through a second time as it's refreshed as well. And like the previous slide, this is 4 hours of data. And we show it daily on the channel. By the way, we are streaming live to Twitch. It's twitch.tv/smAsho. They've got a great mobile app. Thanks to our YouTube subscribers. Please share the content with your friends, foes, science noobs, and science pros. Share with your neutrals. Share with people that know about this stuff. Share with people that don't know about this stuff. We're also on BitChute, approaching 400 subscribers over there. And let's do a cosmology segment. Now, cosmology is super important, as heliophysics is not even really fully understood. And so we would like to understand it. And it's part of the reason why we have a channel. So I consider heliophysics to be part of cosmology, as cosmology is all based on the evolution of the sun, the believed life cycle of stars, and so on, the HR diagram. And to make a long story short, the idea is that we know what's going on in the cores of distant galaxies is all based on understanding what's going on in the core of the sun. And we'll touch again on that later in the cosmology segment. First, let's pick a random number between 1 and 1031. Today's random number is 740, which will coincide with some object, the Neil Gorell Swift Bat X-ray Observatory. 740 is Swift J1753.7-2544, which is a null. So this object has quite a variable X-ray output, as you can see here in the historic chart. We even saw it go into a quiescent state here for a couple of years, about a year and a half, between 2018 and 2020. Here are the past 30 days of its X-ray transients. And let's see if we can get a look at this at the Simbad. So I'll just do a quick search for that. J1753 not showing up. Let's see if it shows up on Aladdin Light. Not showing up there either. And we'll do a quick search for it. See if we can figure out what that is. It is an X-ray source, obviously. And here it looks like we have an article about it. Anyway, we don't want to spend too much time on it as it is part of the daily space weather. Perhaps more about J1753.7-2554 at a later time. Let's talk about the solar storm that happened in 1582, documented by at least some Portuguese scribes. In early March of 1582, across the globe in feudal Japan, observers in Kyoto noted the same fiery red display in their skies too. So we were able to, people were seeing aurorae as far south as Florida and Egypt and southern Japan, as low as 28 degrees of latitude. Saw this particular solar storm. At that part of the sky, all that part of the sky appeared burning in fiery flames. It seemed the sky was burning, wrote Pero Ruiz Soares, an eyewitness in Lisbon, the author of a 16th century Portuguese chronicle. Nobody remembered having seen something like that at midnight. Great fire rose above the castle, which were dreadful and fearful. The following day it happened at the same time, at the same hour, but it was not so great and terrifying. Everybody went to the countryside to see the great sign. There's a coronal mass ejection induced aurora from 2010. And this article is on Cosmos magazine. And sometimes we see solar flares associated with coronal mass ejections, and sometimes we don't. It's part of the reason why we have a channel. I'm sorry, it's not on Cosmos magazine. It's on Universe Today, universetoday.com, about the 1582 powerful solar storm to strike the Earth. We've also got a phys.org article about why we need to get better at predicting space weather. And somebody dropped phys.org a line about our channel. Maybe they'll feature our channel as an article. Since we've repeatedly demonstrated our capabilities, obviously the reasons to be able to forecast space weather are increasingly important, folks, with the increased emphasis on space exploration, moon missions, Mars missions, etc. It's super obvious why we need to forecast space weather better. And so I guess I probably don't have to convince many of our viewers on that. But there is an article on phys.org in the Astronomy and Space section entitled Why We Need to Get Better at Predicting Space Weather. And again, I would remind our viewers that the sun is the Rosetta Stone of all cosmology, because until we understand the way the sun is really doing what it's doing, we will not understand the rest of cosmology. And let me just re-emphasize the fact that I'm about to explain the mechanism behind the solar sunspot cycles and the solar polar field reversal cycles. It's going to happen. We just can't make a video about it until I write the paper and submit it for peer review. At that moment, we'll make a video about it. It should be interesting, and that's today's Cosmology segment. Let's get back to your regularly scheduled data. Here is the 1-year chart of the greater than 2 mega-electron-volt electron fluence, otherwise known as the electron flux, measured by the GOES 16. Here's a 3-day chart of it. We're in a nominal range here, a relatively normal range of electron flux over the past 3 days. Here's the forecast model. The green squares are the forecast. The yellow diamonds are the observation. No argument with the forecast there. Here's a diagram of the atmosphere showing the Van Allen belts, GPS satellites. If you need to pause the video, feel free. Here's a visualization of the Van Allen belts, at least in terms of their electron content. Now, your GPS satellite has to communicate through bands of electrons, which causes GPS errors, which mostly occur around the equator at noon. And here's another diagram. This is a little zoomed in. Keep in mind, this is in kilometers. The last diagram was in miles. And we show this daily as well because the next slide is the F ionosphere layer, located around 300 kilometers of altitude. And you're looking at it in vibrational frequency here. Millions of vibrations per second, known as megahertz. And we've been seeing a fairly wobbly, sudden charge up, charge down scenarios going on in the ionosphere the past few days. A bit of an anomalous ionosphere. You can see it suddenly charging and discharging. And while the resolution of this is only 1 megahertz, it will show you major trends. And it is showing some major trends lately. It's going from suddenly looking anomalous to suddenly looking normal. And we're looking for higher resolution maps of this same stuff. If you've got links, let us know in the comments. Perhaps we'll feature them later. Here's the current image, the most current image at 9 o'clock Universal Time. And this data is derived from Australian Government Bureau of Meteorology's Space Weather Services page. Now we're going to go to meteorology. Here are the jet streams of the eastern world. Some backward jet stream flow once again over the Indian Ocean. Here are the jet streams of the western world. Check out the extreme meridional jet stream bends over the North Atlantic. We've got south to north followed by north to south jet stream flow there in that area just south of Greenland. Doubled up jet stream over the eastern U.S. It looks like it's going to be some cold temperatures in Florida. Shout out to our Floridian viewers. Next, we're going to look at snow real quick. First, the snow water equivalent. And you can see very high, well above 1 standard deviation. How about the snow extent tracker? Actually kind of on the low side for snow extent, near the 1 standard deviation below normal. Although in the normal range right now. And last but not least, the snow mass balance, moving back to around 1 standard deviation, having reached about 2 standard deviations above normal right at its peak. And that is the 4th winter in a row, folks. The 4th season in a row for seeing 2 standard deviations above normal snowfall. It's a 30-year average we're looking at there. That's the blue shaded in region. That is 1 standard deviation above and below the 30-year average, which is that dotted line. Continuing on to look at a real-time map of the snow. And here's what we won't do. Worry about the forecast for through the 8th, because that's too far away. We're going to move it till tomorrow. And this also does show you pressure isolines, folks. Those isolines there are the barometric pressure. There's where the Euro forecast puts things at, we'll move it to 12 noon. There's 12 noon Eastern time tomorrow. There is the snow mass, the snow depth. And there is the pressure forecast according to the Euro forecast at 12 noon Eastern time tomorrow. Here is lightningmaps.org's real-time lightning map. We show it daily. And we've got some lightning in the Gulf. Southwest of Tallahassee, it looks like. Just south of Tallahassee, actually. Some live strikes coming in there as we did the video. And by the way, folks, lightning does strike twice in the same place. Do not assume that because lightning struck someplace that it's now safe there. The idea that lightning doesn't strike twice in the same spot is nonsense. Lightning absolutely has a tendency to strike in the same spot. Imagine if there's a huge magnetite deposit below that spot. Here's a U.S. Doppler radar map, and you can see those strong storms there, mainly associated with the Florida Panhandle. And they look like they're taking their time. Let's take a look at water vapor. And you can see they're getting constrained by dry mass of air both to their north and to their south. Here's the cloud layer, and there's the water vapor, and there's the cloud layer once again. Some sheets of low clouds here over the North Atlantic. Are they caused by cosmic ray flux? Leave us a comment. Let us know. Let us know what you think. Lots of low clouds there. Some very stationary low clouds as well, according to the NASA GOES shortwave radiation map. And when your Doppler radar doesn't show you enough data, take a look at the NASA GOES interactive weather satellite. For example, if you zoom in on your location using the water vapor map, it will give you a great idea of how the system is going to be moving. And without doing any more weather weenieing, are you a weather weenie? Leave us a comment. Let us know if you're a weather weenie. Here comes some bonus of features. We're going to show you the latest data in hydrogen alpha rather. How about the less than 2-minute-old video from El Teide, Spain? Yes, there's El Teide, Spain's ground-based hydrogen alpha filtered telescope, looking at the peak of the hydrogen spectral line there at 6,562.8 angstroms. You can see these active regions up here. Pretty weak sunspot is 2812. I would also invite our viewers to check out our own website, smAsho.com. We saw the writing on the wall a couple of years ago with the self-destruction of big tech and so on. And so, welcome to the DR Renaissance. Today's featured product is the Do Not Pole Vault the Caldera products. There are 50 of them. And I'm about to order a set of the socks myself. Do Not Pole Vault the Caldera. It's also in masks and throw pillows and comforters and duvet covers and tote bags and mugs and mounted prints and phone cases and a bunch of shirts. And again, you can link to all of that at the smAsho merch link on our homepage, smAshomash.com. And do not pole vault the Caldera. Our patrons know better than to pole vault the Caldera. Thanks to our patrons. Please consider becoming a patron, as we need lots more funding to accomplish our goals in the year 2021. Patreon.com/smAshomash is the URL. Thanks to Smash Team. Again, please don't forget to press like, press subscribe. Tell your friends, tell your foes, tell your science noobs and science pros about the channel. Smash News Network, least busted name in news. So we're going to show you some bonus features here in the form of the ultra-high resolution colorized intensity magnetogram and the ultra-high resolution intensitygram. So here's the intensitygram, sunspot 2812 looking weak, as the trailing umbra now still there. So it's about to get downgraded again to an alpha class sunspot, folks. There you can see the trailing umbra is now the main umbra. So it's probably going to get downgraded. Here's another full disk view in 171 angstroms. And we've got an additional close-up of the most active region, the northwest quadrant, along with a great Earth scale to show you the size of active region former sunspot 2811, which is the one kind of right under the Earth there. Some great views of the filamentary activity there, overlapping off the side of the limb, as well as sunspot 2812. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance, and may that solar wind be at your back.